Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 8.3.1 part 2, problems 130 through 135. Problem number 130. This is fun. This is us getting ready for work we're going to be doing in chapter 9, which is right around the corner, looking at angle relationships. Here we have a straight line broken up into two angles. One of them is less than 90. Oh, stop it. One of them is less than 90 degrees. And one of them is greater than 90 degrees. So angle A is an obtuse angle. And we have learned in the past that straight lines, straight angles, measure 180 degrees. So if I take this right here, you can see that to go from 0 all the way over to here is 180 degrees. Or if you use the outer number line, same idea. So all straight lines always are 180 degrees, which makes these two angles what we call supplementary angles. Supplementary angles are angles that always add up. Their sum is 180 degrees. So we solve this algebraically. 180 is going to be equal to, no, it's not. No. A is going to be equal to 180 minus 80. So that's how we got 100 here. These are what you refer to as vertical angles. And if you know these angles here are supplementary and these angles here are supplementary, if these two together make 180 and these two together make 180, then the total makes 360. Now, notice something interesting that's happening here. Anytime two lines intersect each other, the angles that are across from each other look like they are the exact same measurement. And there's a reason why they look that way. It's because they are. So vertical angles are always going to be what we call congruent to each other. So if we know this, we know all four of them, because we know that 180 minus 43, 180 minus 43 is 137, that this is 137, then these two have to be supplementary, so that has to be 43, and then these have to be supplementary, which makes this 137 as well. So just by working our way through these supplementary angles, we start to see, oh, the ones across from each other have the exact same measure. Those are called vertical angles. Same idea here, these two are supplementary angles, so they will add up to 180. These two are supplementary, so this has to be 32. These two are vertical. This has to be 148. And just to prove, add 32 and 148 because this is forming 180 degrees. Yes, everything works out beautifully. And then same idea here. These are supplemental. So what do you add to 111 to give you 180? That would be 69. Is that it for this one? Yes. All right. More to come with that in chapter 9. All right. Daniela has $210 in the bank, and her balance is growing at a rate of $3 each month. Lori has $187 in the bank, but her balance is growing at a rate of $450 a month. So Daniela starts with more, but she's saving less. Lori starts off with less, but she's saving at a higher rate. So at some point, Lori is going to surpass Daniela. And so what we want to do is we want to figure out after how many months, that's our unit of time, will they be the same? And then eventually, Lori's going to catch and pass her. So if B represents the bank's balance and M represents the number of months, then if B is equal to this and B is equal to that, then this must be equal to that. So let's go ahead and solve for M. 3M plus 210 has to be equal to 4.5M plus 187. I'm going to subtract 3M's from each side, and I'm going to subtract 187 from each side, and you get in 1/2 of a month, or whatever that is. I don't really know if that's the interpretation. Okay, I'm going to add up here. That's going to be 323. right? When I add 3 to this, it's 190, and if I add 20 to 190, that's 210. So yes, that's going to be 23. So if I divide each side by 0.5 now, 23 divided by 0.5. Did I do everything correctly? I'm gonna. That's gonna cause a zero pair. That's gonna cause a zero pair. That's 0.5. That's definitely 23, right? Yeah. So let's see what this does. 23 divided by 0.05 is 46. Where did I make my mistake? No mistake. Did I just do the adding wrong? Oh, that's not 0.5. It's 1.5, people. All right. So you'd want to check everything to make sure, and because I had my answer there, so I knew something was wrong. But if you check, then I would have caught that mistake as well. So this is supposed to be 1.5. So let's try again. 23 divided by 1.5 is, there you go, 15 and a third months. They will both have $256 in the account. How do I know they're going to have 256? It's going to take this and multiply times 3, and then add 210, and it gives me 256. If I take 15.33333333333333 all as far as I can go, and then multiply that times 4.5, then I add that to 187. It's pretty much $256 there as well. All right. So remember, system of equations. Set up your two rules where B represents the same thing in both situations and M represents the same thing in both situations. Then you can find the intersection point of their line by finding the solution to the system of equations. And that intersection means something in the context of the problem. In this case, the intersection is where they have the same amount of money after the same amount of time. All right, candy stores specialty is taffy. Customers can fill a bag with taffy, and the price is based on how much the candy weighs. The store charges $2 for 10 ounces. So that must be how much per ounce? If you take $2 and divide it by 10 ounces, that's going to give you, looks like 20 cents per ounce. Okay, so that's the unit rate, right there. So 2 ounces would have to be 40 cents, 5 ounces would be $1. We already know 10 ounces is $2, and 20 ounces would be twice that. So this is definitely a proportional relationship, right? Because if you buy no candy, you pay no money, right? So 0, 0 is going to apply. Here is, oh, I guess I don't have the unit rate is going to be somewhere around there, but I don't have it labeled in there. But definitely, here's the 5 for $1, 10 ounces for 2. And why did I not line this up properly? That's weird. Why would I ever do something like that? Oh, well. Moving on. All right. Is this situation proportional? Explain your reasoning. Yes, it is definitely proportional because it goes through 0, 0, and it's a straight line on the graph. What is the slope of the line you graph? Well, the slope would end up being the unit rate, right? For every, oops, stop it. For every ounce that it increases, it's increasing by 20 cents. So that ends up being the slope ratio. And the equation that fits for this is the unit rate times the number of pounds equals how much you're going to pay. So just to prove that, if we bought 20 ounces, 0.2 times 20 is $4. So when we go and we look at the graph, we look at this, that works. Actually, 20 ounces was $4. Yes, that works as well. Okay, so that's the rule. All right, and then solve each equation below for the given variable. All of these are one variable equations, so that makes things a little bit easier. In this case, pretty straightforward. Subtract 3 from each side, add 11 to each side, then divide by 3. This one's going to require some distributive property, combining like terms, then adding or removing balanced sets before you finish the process. This, technically, this one looks kind of tricky, but let me show you how to do this. 10 can be written as a ratio of 10 over 1. So if we cross multiply we end up with 10 times k minus 12, which is 10k, no, 2, which is 10k minus 20, will be equal to 6 times 1, which is 6. So when we add 20 to each side, that becomes 10k is equal to 4. No, it's not. It's 26, isn't it? And then when you divide by 10, most people will most likely give the decimal answer. K has to be 2.6. Now I'm curious. 6 divided by 2.6 minus 2. 2.6 minus 2 is going to be 0.6. So is 6 divided by 0.6 equal to 10? I think it is. Let's check. 6 divided by 0.6 is equal to 10. So that proves our solution is correct. So you always want to check these. Oh, I should probably do D as well, shouldn't I? All right, move this over to there, change my color to green, and no, change my color to green, and then do that. Yes, that's good. Okay, so I'm going to cross multiply. I'm supposed to change to green, people. Please, cross multiply. So this becomes 4 times x plus 3 will be equal to 2 times 3x minus 1. Send in the dive bombers. And by the way, that's really all you need to know at this point. That's how you go from here to here. At this point, it becomes just like this problem, where you send in the dive bombers, combine like terms if you need to. In this case, we don't. We're just going to take away 2 x's from each, or 4 x's from each side. And at the same time, add 2 to each side. And now we went from this to that to this to this. Much, much easier to get to our solution after getting rid of those fractions. Okay, so the answer is going to be 7. We can prove that it's 7 by making this 21 minus 1 is 20. So it's 4 over 20, the same as 2 over 10. Yes, they are equivalent to each other, so we feel good about our answer. All right, scientific notation. Multiply leading factors first, then the powers of 10. In this case, the leading factors ended up giving you an answer that was 10 times 10 to the negative first. We don't like that 10 being there, so I'm going to divide it by 10 and make it a 1, and then move that over to here and add the 10 to the first time, or have 10 to the first times 10 to the negative first, which when you add the exponents, that's how you get the zeros there. So technically, the answer to this problem right here is equal to 1. 1 times 10 to the 0 power. We could have just said 10 to the 0 power, but I would have most likely just called it 1. I want to do this on the scientific calculator. I want to just prove that. Come on, scientific calculator, what's taking you so long? Let's go to here. Let's go to here. Let's go to there. And what was the problem again? It was 4 times 10 to the second. Dude, you're killing me. Urgh. Clear. Go. 4 times 10. Oh, okay. I'm going to. My computer's not working. Let me pause and get this in. I'm going to swear at my computer a little bit. Whew, oh, that felt good. I got a lot off of my chest there. You didn't have to hear any of it, so good for you. All right, it's working again. You just have to talk to it the right way. All right, so 4 times 10 to the second times 2.5 times 10 to the negative third. If we hit equal, our answer should be 1. See what it shows us. There it is. That's our answer. All right, so we did everything correctly, simplifying that. And then for problem C, go ahead and move this guy over. 2.5 divided by 5. If you thought that said 25 there, I can understand you maybe got a different answer, but 2.5 divided by 5, 5 divided by 5 is equal to 0.5. So this becomes 0.5 times 5 minus 8 is 10 to the negative third. So we're going to have to borrow one of these guys. And you're going to take away, this is where, you know what, maybe we just need to do this. Let's just say 0.5 times 0.001. That's 10 to the negative third, right? 1 is in the third decimal place. Now let's figure out what that is, times 0.0001, and that gives you 0.0005. And now your 5 is in the fourth decimal place, so that becomes 5 times 10 to the negative fourth. Did I mention this was kind of complicated? It is. I totally understand, and that's why I don't want to put anything too complicated on the chapter test. This is all brand new. You're going to have to use it in your high school science and all. By the time you get there, hopefully you'll feel a little bit more comfortable with some of these exponent processes, and you'll be able to use your scientific calculator, of course, along the way. And when are we done? Is this the last one? It seems like this is going on forever. How much time is this? Yikes, not too bad. Okay, so this problem is checkpoint for transformations. It will be referred to as checkpoint 8. Okay, so at this point, we want you to know how to do all transformations in 8th grade. So take the original ABC here and translate it 2 units to the right, 1, 2, and 3 units up. That would be the new image after translation, and these are the new vertices. That's 1, 2, negative 2, 2, and this is negative 2, 0. Then we have to reflect it across the y-axis. So this is the one that's across the y-axis. These are all the points. Then we rotate it 90 degrees about the origin. I'm not a big fan of that. Oh, why did I do this? I guess I got kind of lazy. But yeah, after rotating it 90 degrees about the origin clockwise, you just, kind of remember that, let's not do that. Let's do this guy. Just do that in that color, that thickness. Okay, so you want to take this point and then form a right angle to this point. And you kind of get an idea of where it's going to go. So this one's going to take 1 to the right and up 1, so 1 to the right and up left. So yeah, it's confusing. But that is definitely the one I would expect people to struggle with because it's not easy. But it can be done if you just remember a 90-degree rotation. There should be right angles going through the origin from the original point to the new point. And then the scale factor. Scale factors, we're going to take our x and our y coordinates and we're going to double the x's and double the y's. So basically just taking each one of these points and multiplying both the x and the y times 2, you end up getting these as your new shape. All right, that does it. We have completed our homework for chapter 8.3.1, and now we're going to get into a mode where we are preparing for the chapter test. Today I'm going to have a little assessment on functions that I'd like for you to take. Then we're going to do the study guide the next day, and then we are going to take the chapter 8 test number 2 at the end of the week. That's assuming you're in current time. If you're in the future sometime listening to this, just forget what I just said. Okay, what do I need to do? This, and goodbye. Talk to you later. See you later.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling